Hey everyone, this is Som. Welcome to Civil Basics. So, we are going to deal with strength of materials in this video lectures. So, I have written down the topics which are going to be dealt. So, the first one is support reaction, second is shear force and bending moment diagrams, third is your center of gravity and a moment of inertia, fourth is torsion of shafts, fifth is deflection in beams, sixth is your deflection in cantilever beams. These two are of the same chapter, but I have separated them because they are a bit lengthy, so I separated them. Seventh is your simple stress and strain, eighth is your principal stress and strain, 9 is your shear stress in beams and bending stress in beams, 10th is thin cylindrical vessels, 11th is theory of columns and struts. Now, before starting with support reaction, I want to give a basic of strength of materials, that why we study it. See, strength of materials is a branch of science that deals with strength of materials, deals with behavior of a body, how the body behaves, body, and of a solid body. This will be solid when it is subjected to various kinds of load, when the solid body is subjected to various kinds of loads. Due to application of various kinds of load, there are some internal forces which are being developed in the bodies due to these loadings. So that's basically the motto of our study, that we will be dealing with the behavior of the body. Okay, now our objective of our analysis the objective of our analysis is to determine the stress, strains, shear force. I'm writing them: stress, strain, shear force, bending moment, deflection, etc. So these things are produced by the loads in different structure. So these structure may be, like example, beams, columns, frames, trusses, etc. Now I will be telling you about the type of supports, types of loadings, and types of beams. So there are three categorization of it. So first we will be seeing types of support. So this is a simple support. This is a simple support, and this is number of unknown or restraint. That means where the body or where the support will give reaction, because it cannot move in this part. Okay, and this is possible moments or degree of freedom. That means body can move in, like H and R is written, so this support can move in horizontal, and as well as rotation will come in it, but it cannot move vertically. In roller, see, two wheels type structure is applied here, and this is the fixed, so it cannot move upwards. So there is one restraint which is vertical. It cannot move vertically, but yes, it can move horizontally. That's why degree of freedom is horizontal here. And rotation will also come because it is hinged here. That's why it will be moving like this. It can have movement. Third one is hinged. So hinged cannot have horizontal movement because it cannot move in horizontal direction as well as vertical direction because it is fixed here, but it will have a movement because of hinge present here. That's why it is known as hinge support. Fixed support is like it is fixed here, and so it will have 0 degree of freedom because it cannot move in horizontal as well as vertical as well as rotation. It cannot be there. So number of unknowns are horizontal, vertical, and restraint, or sorry, R is rotation. Now guided roller can move vertically because see the rollers are present here, so it can move vertically in vertical direction, but it cannot move in horizontal because it is fixed here, it is not hinged, so it cannot move in horizontal direction. As well as rotation will not come here because there is no hinge present here. Now we will be seeing types of beams. So the first type of beam is cantilever beams. See, cantilever beams, one end is fixed and the other end is free. Then there is propped cantilever beams. In this, one end is fixed, other end and another part, if we name this A, B, C. So B is having a roller support and the C part is free. In simply supported beams, just any kind of support is present here in the ends. Fourth is your overhanging beams. So two, like if we name this A, B and C, two parts are in supports and the third part is free. Fixed beam, it is fixed both side fixed, support is there. Sixth one is continuous beams, which is you can also see in the diagram, it is continuous, supports are present here, and so on. Then we come to types of loadings. See, first one is concentrated load. That means this is a simply supported beam, these are simple supports, and a load W, this is also point load, is applied in this beam. So this is concentrated load, it is denoted by this arrow pointing downwards or upwards. Second is uniformly distributed load, it is denoted by this kind of sign. This is suppose a simply supported beam and load is applied, which is W per meter run. Load W is acting all along the length, all over. It is also denoted by this kind of type. Then there is uniformly varying load. In this, what happens, one end, the load in one end is 0 and the other end is highest load is present, which is W per meter run here. So W load is acting here and it goes on decreasing when moved along the beam. See, in here also, simply supported beam having a uniformly varying load, it is uniformly varying. So there are 5 types of problems which we will be discussing. The first one is problems based on simply supported beams. Second is your problems based on overhanging beams. Third is problems based on roller and hinge supports. Fourth is problems based on inclination, that means loads are inclined here, loads will be inclined. Fifth is your problems based on beams subjected to couples. So moving ahead with case 1, problems on simply supported beam. See, there is a question given: a simply supported beam AB of length 6 meter carries a point load of 3 kN and 6 kN at a distance of 2 meter and 4 meter from left end A. Find the reactions at the point A and B. So we are asked about the reactions here. So first of all, we will be drawing the diagram of it. So AB, this is A, this is B, it is simply supported. So now it is saying this is of 6 meter, as mentioned in the question, carries a point load of 3 kN and 6 kN at a distance of 2 meter and 4 meter from left end A. So this is end A. So from here in 2 meter, at 2 meter length 3 kN load is applied, and at 4 meter length, this is 2 meter, 6 kN of load is applied at a distance of 4 meter from A. So we have to find the support reactions here. two reaction will come, RA and RB. As you know, this is a simply supported, so only vertical reactions will come. See, this is support, simply supported beam, so one reaction vertical will come only, so we will be calculating it. Now we know summation of Fy is equal to 0. That means 3 plus 6 equal to Ra plus Rb. These are the equilibrium conditions. So Ra plus Rb will be equal to 9 kN. Now we will be taking moment across A. So taking moment at A, it will be also be equal to 0, because it should satisfy the equilibrium equations. So now I am considering here that clockwise moment is positive and anti-clockwise moment is negative. So Ra, it will be 0 because no distance is here, so Ra will be Ra into 0. Now 3 will be in this direction, 3 will be in clockwise direction, so it will be positive. Load into the distance, perpendicular distance, which is 2 meter. Same applies for 6 plus 6 into this distance, which is 4. Now for Rb, when it tries to move towards A, it will be anti-clockwise direction, anti-clockwise, so it will be minus. So 6 Rb equal to 0. Now we can find out the value of Rb here. 6 plus 24 minus 6 Rb equal to 0. That means 6 Rb equal to 30, Rb equal to 5 kN. Now as we have found out Rb equal to 5, so Ra can be from here 4 kN. So these are the two reactions which we found out. So in case 2, problems on overhanging beams. This is an overhang beam given, and a uniformly distributed load is applied here over the span, all over the span. So and a point load is applied at the end of the beam, which is of 2 kN. This is 2 meter, so the overall span of the beam is 6 meter. 4 plus 2. Now we have to calculate the reactions. So we will be applying the same method. Ra plus Rb will be equal to 2 plus, now this load, which is of 2 kN per meter, we have to multiply it by the distance, because it is uniformly distributed load, and like this is the load is 2 kN per meter. Now if we multiply it by the distance, it's 2 kN per meter into 6 meter, because it is applied on overall length, which is of 6 meter, so it will be 12 kN. So 12 plus 2, it will be 14 kN. Again we will be taking moment across A, which is equal to 0. This is phi equal to 0, and we will be taking the moment. So the load is 12. This load always acts on the CG of the beam, so the CG of the beam will be 6 by 3, because total length is 6, and if we half it, it will be 3. So 12 into 3, load into CG distance, minus 4, this is anti-clockwise, so 4 into Rb, 4 into Rb, and this 2 kilonewton is acting clockwise. So this 2 into the overall distance, which is 6 meter, plus 2 into 6, which is equal to 0. Now we will be calculating the value of RB. So 4 RB is equal to 6, 12, 36, 48. So RB will be 12 kilonewton and RA will be 12 minus 14 minus 12, it will be 2 kilonewton. See, whenever you are calculating the moment for an uniformly distributed load, now what you do is, this is the load which is given to you, 2 kilonewton per meter, multiply it by the total span, which is 6 meter here, and then the CG distance, that is 6 by 2. That what I have done here, 12 into 3. Now we will be seeing case 3, which is problems on roller and hinge supports. So this is the question given, and you have to calculate the support reactions. So this is a hinge support, so it will be having 2 restraints or unknowns. One is, let's suppose this is A and this is B, and this will have only one RB because it is roller support. It cannot move upwards, but it will have movement, and it can move horizontally. This cannot move horizontally, and it cannot move vertically also. Only moment comes here. So here the another equilibrium formula, Fx will be equal to 0. So all the horizontal force will be equal to 0. So HA, which we considered as horizontal force, will be equal to 0. So it's done here. Then Fy. Now see, there is a uniformly varying load is given. So how can we calculate the load which is being applied here? So this is the load given basically. This is 15 kilonewton per meter, and this is applied in 4 meter. So for calculating the load, we just find out the area of this triangle, which is half into 15 into 4, which is 30 kilonewton. Half, this is the height, and this is the base. Half base into height, which is 30 kilonewton. Now for the CG, what we do is, it is a triangle. So from this part to this, it will be L by 3. That means 4 by 3. And if you take from this side, it will be 2L by 3. That means 4L by 3, which means 4 into 4. So it will be 2. So 2 into 4 by 3 is 8 by 3. So applying Fy equal to 0 here, that means Ra plus Rb will be 20 plus the load here, which is 30 kilonewton. 30 equal to 50 kilonewton. Now when taking the moment, we will be needing the CG. So it will be moment at the rate A, we are taking moment across A. So Ra into 0, and 20 is moving clockwise towards A. So 20 into 4. This load will be also clockwise, but see, this load will be acting here to the CG, and this distance is 4 by 3. So 4 by 3, which this will be plus. So this plus 4 by 3. 4 plus 4, 8. 8 plus 4 by 3, which is 8. 4 by 3 is, I am writing like this, load into the CG distance, which is 4 plus 4 plus 4 by 3. Okay, and minus 12 RB. 12 into 4 plus 4 plus 4, it is 12, and it is anti-clockwise in direction. So it is 12 RB equal to 0. So if you calculate RB here, it will be somewhere around 29.99 kilonewton. And if you have got the RB, that means RA will be 50 minus 29.99, which is 20.01. So the next two cases we will be seeing in further videos, and if you like this video, then please like and share. Thank you.